Hello everyone, and this video I'm going to show you the formula for energy conservation. Okay, and energy conservation is also the central part of physics. Okay, just like Newton's law of motion. Newton's law of motion and energy conservation is the most central part of physics. Okay, but energy conservation is much easier than Newton's second law of motion. Okay, Newton's law of motion. Okay, we all start from the work kinetic energy theorem. Okay, previously we have shown the work kinetic energy theorem. Your work add in your system or pull out from your system is equal to the difference of kinetic energy between the final state and initial state. And then we just start from this work kinetic energy theorem when we'll reach the famous energy conservation equation. Okay, and in previous section we have introduced or make we will have introduced we can classify the work done by the conservative force and non-conservative force. So we can start from here. Okay, in the work kinetic energy theorem, we didn't we didn't make a clear detail of this work. We just say it's work, total work. Okay, but right now we know there is the work done by the conservative force and non-conservative force. Conservative force like spring and gravitational force. We just show the spring force and gravitational force is a conservative force, and friction is non-conservative force. Okay, so the W we can make a contribution. Okay, we classify it's conservative, and non-conservative, conservative. Okay, because this word is too long, so I just make abbreviation. I say WC plus WNC. Okay, and in the previous section, we have shown that the work done by the conservative force is equal to what? Do you remember that? The work done by conservative force is equal to minus UF minus UI. Okay, or some would write this. Some books will write WC is equal to WC is a toilet. WC equal to minus delta U. Okay. So we add this to our working energy theorem. So okay, what will we have? Okay, so okay, so W equal to WC plus WNC. So WC plus WNC is total work equal to KF minus KI. And now we have the work done by conservative force is minus UF minus UI. So this term is minus UF minus UI. Okay, and then rearrange it. Rearrange it. We'll finally reach this KF minus KI plus UF minus UI and equal to the work done by the conservative force. And okay, so this negative sign has some function. And previously, I said previous video, I say this minus sign has some function because if you don't have minus sign here, you'll reach a very weird you will reach a very weird conclusion. So the minus sign here is for you have to make the energy conservation formula work. Okay, that's why you need the minus sign here. Okay, if you don't have minus sign here, yeah, you will have very weird you have a very weird formula. Okay, okay, that's why you need a minus sign here. And we almost done this almost the energy conservation formula. So, okay, but next thing we have dealing with the right hand side. In the right hand side, I just make a trick to dealing with right hand side. What's the work done by a conservative force? Okay, so that's dealing with the right hand side, and that just makes this formula more general. We want to make this formula more general. So finally, I would say, this is almost the this almost energy conservation, but we want to make this formula more general. So I would say this. Finally I will make the energy conservation equation like this: as UI equals to Q plus work done by the external force. Okay, Q here is heat. Okay, Q here is heat. And XT is work done by the external force. Done by external force and external force. Okay, so this is energy conservation. This for the red one is called energy, energy, energy conservation. And now I tell you some convention for the Q and external force. Okay, so very important about convention, the sign convention. Okay, for Q is a heat, right? So it's Q. If it's Q, we have sometimes we have the minus sign and plus sign. The minus sign is release heat from system. Release heat from system. Okay, and the plus sign for Q is add heat into system. Okay, that's my convention for plus sign and minus sign. So the same thing will happen on the work done by external force. We also need to clarify the convention. Okay, the sign convention is very important, especially in energy conservation calculation. Yeah, maybe in the future you choose chemical engineering, you understand what I'm talking about. And chemical engineering, you have to do lots of energy conservation calculation for 4 years. Okay, you will know if you choose chemical engineering. Okay, so W, okay, we also have the minus sign and plus sign. Okay, the minus sign is the work. Work is done by the system. Done by the system. From system, the work is done by the system. I want to say it's from system to outside, system to surrounding. Okay, work is the work. The work is from system to surrounding. To surrounding. So that means sometimes your system can do work to surrounding. Okay, but I think in most general physics textbook, in general physics textbook, always the work is done from outside into your system. But actually, in the future, maybe you're in other engineering department, you will know sometimes your system can do the work to outside. If in that situation, we have a minus sign in front of we call it minus sign because we're system. The work is done from system to surrounding, and it's minus sign. And reverse the process. We add the work into the system. That's the plus sign. Okay, add the work into a system. Add the work into your system. Okay, that's plus sign. That's plus sign. Okay, there's a sign convention for the heat and work done by external force. Yeah, you will find a trend. Okay, you'll find a pattern, a feature. Will add something into your system. That's positive sign. You something leave your system. That's minus sign. Okay, so leave the system minus sign. Add into system plus sign. Okay, so this is more general equation. So if your system no external force, This is for general equation for energy conservation. When if sometimes if your system no NC force, non-conservative force, no NC force, and no external work, and the energy conservation will reduce to Kf minus Ki plus Uf minus Ui equal to 0. And some books call these equations called mechanical energy balance. Mechanical energy balance. Okay, and it's more. Yeah, it's more simplified, simple one. Okay, because of the, sometimes your system no heat, no work. Yeah, it's also some system can be treated this way. Yeah, some system can treat like this way. Okay, mechanical energy conservation. Okay, so this video just show you the formula for energy conservation, formula for energy conservation and mechanical energy conservation. Okay, and then we'll use this formula in this section a lot. Yeah, it's also like I say, this is a central part of physics, energy conservation calculation. It's just like Newton's law of motion, or Newton's second law of motion. It's the heart of physics. Okay, so we will demonstrate some example in later video, and hope you can familiar with formula. Hope. Okay, I'll stop video here. Thank you for your attention. We'll see you next video. Bye bye.